Welcome to Algebra 1, Section 1.8, Introduction to Equations. By the end of this lesson, you should be able to differentiate between a true, a false, and an open equation. Use mental math to solve simple open equations. You should also be able to test a possible solution to be an answer to an equation. You should be able to use a table to find a solution. You should also use a table to be able to estimate a solution to an equation and be able to write an equation from a word problem. Sounds like a lot, so let's dive right in. First off, true, false, and open equations. A true equation is something that has two equal sides. So for instance, if I had something like this, 4 times 5 on one side, which we know to be 20, then on the other side I've got 3 times 6, which is 18, and then add 2, that makes 20. So I have 20 on both sides, which makes that a true equation. And just opposite, a false equation has two unequal sides. So for instance, on this one, I've got 45 divided by 9, which is 5, and then add 6, that gives me 11 on the left-hand side. On the right-hand side, I've got 30 minus 20 minus 1, that makes 9. So 11 does not equal 9, so that is a false equation. However, the type of equation that we're used to seeing, we call an open equation. It could be true or it could be false depending upon the value of the variable. So for instance, if I have 3x minus 5 equals 13, that might be a true statement, it might be a false statement. Typically what we do with an equation like that is we try to figure out what the variable is that would make it true. So we'll get to that more in detail in the next chapter. But the main characteristic of an open equation is it has a variable. If it does not have a variable, then it's either it's either a true or a false equation. For simple equations, we can use mental math to find the answer. So for instance, for this simple equation, x plus 5 equals 9. We can simply ask ourselves, okay, so there's one number that when I add 5 to it, it gives me 9. You could probably figure that out pretty easily. You know that x equals 4. There's some number that when I multiply it by 3, it gives me 27. You probably already know that that's 9. Or there's some number that if I take 28 and divide it by some number, that would give me 4. You probably already figured out that that's going to be 7. Because 28 divided by 7 is indeed 4. Now, I don't particularly care for this because we're going to be dealing with much more difficult equations, and we're going to learn a very step-by-step process to solve those equations. But on the other hand, it is good to be able to take a look at something and reason, does it make sense or not? Next thing I want to talk about is testing a solution to an equation. This is going to be very handy down the road when we solve equations. And once we get our final equation, we want to test it and make sure that it's the correct one. So we're going to do this process. So this isn't just something that we can blow off. This is something that we need to hold on to for a while. So this first question is x equals 5 a solution to 8x minus 13 equals 24? So here's how we're going to do this. We're going to take 8x minus 13 equals 24. And where the x is, I'm going to take that x out and replace it with that 5. So now I can go ahead and do my little PEMDAS thing. I've got 8 times 5 minus 13, so that's 40 minus 13. So 40 minus 13 is 27. But on the other side of the equation, I've got 24. So that is a false equation. So therefore, x is not a solution. Let's try plugging in negative 3 into this next equation. So is x equals negative 3 a solution to 5x minus 18 equals 12x plus 3? So I'll do 5. And then I'll put negative 3 where x is. And here's the thing, I have to put it everywhere that I see an x. So I have to put it where that 12x is as well. Now, when I do my order of operations, my PEMDAS, I'm going to do everything on one side first, and then use my PEMDAS on the other side. Don't use PEMDAS on the same side. Well, you could, but it's just easier to keep one side straight and then worry about the other. So 5 times negative 3 is a negative 15 minus 18. And then negative 15 and negative 18 make a negative 33. Moving over to the other side, 12 times negative 3 is a negative 36 plus 3. That makes negative 33. So yes, it's a true statement. So x does equal negative 3. Last example. Is x equals negative 2 a solution to 3x squared plus 4x minus 7 equals negative 3? Ooh, this is a doozy. So I'm going to plug in that negative 2 everywhere I see x. So 3 parentheses negative 2. Anytime that I'm plugging in a number, especially a negative number, I like to put parentheses around it. So that way I know that the things outside the parentheses are affecting both the negative and the 2. So, order of operations. First thing I'm going to do is parentheses. I can't do anything inside the parentheses because negative 2 is just negative 2. So I move on to exponents. So negative 2 squared, that means negative 2 times negative 2 is a positive 4. If I didn't have those parentheses there, that might have screwed me up a little bit. So now I can multiply. Let's see, 4 times negative 2 is a negative 8. Now let's move on to the adding and subtracting. So 12 minus 8 is 4. 4 minus 7 is negative 3. I get a true equation. So yes, x does equal negative 2. Again, this is going to be very handy for checking our answers once we get to the solving equations chapter. So make sure you understand it. Next topic I want to cover is how to use a table to solve equations. I'll be real honest with you, this isn't my favorite topic because next chapter we are going to learn how to solve this equation step by step as opposed to making a table, which is basically a glorified guess and check. So we'll go through one example, and then other equations like this, we'll learn how to do it in Chapter 2, and we'll learn how to do it much more efficiently than using this table. So here's the idea with a table is that you pick numbers for x, so you just guess. Is this the answer? So let's go ahead and try 2. If I'm going to take that and plug it in, so I've got 3 times 2 minus 8 equals negative 14. 3 times 2 is 6, so 6 minus 8 equals negative 14. That gives me, what, negative 2? So is that a solution? No. All right, let's try, I don't know, 4. So 3 times 4 minus 8 equals negative 14. So that's 12 minus 8. So 4 equals negative 14. All right, so take a look at what happened here. I went from negative 2 equals negative 14 to 4 equals negative 14. So if I kept choosing bigger numbers, I'm going to get further and further away from negative 14. So how about I go the opposite direction? Instead of going for bigger numbers, let's go for smaller numbers. 0 I could do pretty easily. 0 minus 8 is negative 8. Now, that's not it. So let's go less than 0. How about negative 2? So 3 times negative 2 is a negative 6 minus 8. So negative 6 and a negative 8 makes a negative 14. Okay, there we go. We finally got it. We had to do some guessing and some checking, but we figured it out. Again, we're going to use a much more efficient method of solving equations. So I showed it to you. I did my job. I don't want to ever have to use that again. All right? All right, so let's take a look at this one. This time it says estimate the solution. So again, we're going to just pick a number. Let's try 5. So 7 times 5 minus 15 is 43. 7 times 5 is 35. And 35 minus 15 is 20. That's not it. So let's go bigger. Let's try 8. So 7 times 8 minus 15 equals 43. 7 times 8 is 56. 56 minus 15 is 43, or 56 minus 15 is 41. All right, so we jumped from 20 equals 43 to 41 equals 43, so we're getting much closer. So maybe it's 9. So 7 times 9 is 63. 63 minus 15 is 48. All right, so we did it at 8, and the answer of 41 was too low. We tried it at 9, and the answer of 48 was too high. So that tells me that my answer has to be in between 41 and 48 in order to be 43. So the answer is in between 8 and 9. So my answer is probably going to be a decimal if I were working this out the precise way. But I just used a table to kind of estimate where it's going to be. I don't know what it is exactly, but I do have a good ballpark now. Again, this method is very long and tedious. We can get an exact solution very easily by doing what we're going to do in Chapter 2. So again, I showed it to you. Hope you learned something, but probably not going to use this a ton. All right, last topic, word problems. Everyone's favorite, I know. So let's go ahead and read these word problems and see if we can come up with an equation for them. It says the price of a candy bar is 10 cents less than double a package of gum. If a candy bar is 90 cents, how much is a pack of gum? Well, let's go through and let's highlight some key words there. So some key words I'm seeing, the price of a candy bar is, and then I see 10 cents less than double a package of gum. Okay, so let's identify our unknowns here. I have no idea how much the price of the candy bar is, so we'll use C for candy bar. And 10 cents less than double a package of gum. I have no idea what a package of gum is. So, well, I know what it is. I don't know how much it costs in this problem. So I'll use G for gum. So now I'm going to use the skill that we learned at the beginning of the chapter, where you translate words into expressions. So it says, the price of a candy bar is. Well, candy bar is C. Is represents my equal sign. And then 10 cents less than, there's that phrase less than, that tells me to switch it around. 10 cents less than double a package of gum. So double the gum. There's my equation. Now later on it says if the candy bar is 90 cents, well, I'll just plug that 90 in for the candy bar. Now let's use a little mental math. If there's 2 packages of gum and then I take away 10 cents, that leaves me with 90 cents. Well, if I put that 10 cents back on, that'd be $1. So what 2 numbers could add up to be $1? Well, that'd be 50 cents. And again, we're going to use a much better way of solving equations than that. Right now, I'm more focused on you setting up the equation. Next problem. The length of a fence is 7 more feet than the width. If the perimeter of the fence is 86 feet, find the length and the width of the yard. So my unknowns here, I have no idea what the length is. I have no idea what the width. It says the length of a fence is, so the length is 7 more, that means to add, 7 more feet than the width. So there's a good equation right there. The length equals 7 plus W. And it says the perimeter of the fence is 86 feet. Ooh, perimeter. That's a pretty good word right there. You may remember the formula for perimeter to be 2L plus 2W. So now what I'm going to do is I'm going to plug in everything I can into that equation. I know the perimeter is 86. And since my length is 7 plus W, I'm going to put that 7 plus W right where that length is. So 2 parentheses 7 plus W. And there's my equation. Now, I'll tell you what, this is not an equation that we're going to be able to solve mentally. Well, we can, but I wouldn't expect you to solve something like this mentally. So I just wanted to show you this example just to kind of show you how we can take words and translate them into sentences, into number sentences. So that being said, if you guys have any questions, please feel free to email me, and I will see you in class real soon. Have a good one.